أعوذ بالله من الشيطان الرجيم بسم الله الرحمن الرحيم. Sample size calculation has always been a problem for social sciences researchers. We are always thinking about what is an appropriate sample size. Now, there are a number of recommendation considerations when estimating a sample size. And sample size for survey research is obviously most of the times a cause of concern for young scholars or those who are even preparing their paper or thesis. Now, I've come across this very good read on sample size for survey research. The paper is, I would say, summarizes all the necessary concerns, all the available resources, most of them when estimating a sample size. So I strongly encourage the researchers to read this paper. Although it was published quite some time ago, and I've been using the recommendations in this paper for quite some time, I thought that it is a good idea to share it with my viewers as well. Now, I'm not going to go into detail and read everything that is in there, but I've got a few points that will help the scholars in estimating their sample size. The link to the paper and the reference will be shared in the description. Now, there are a number of factors that influence our sample size decision. Now, what is the nature of our research? Now, a number of times I have been asked this question that I am trying to conduct this research on people that are holding the top positions in the organization. Now, they are CEOs, CFOs, HR managers, maybe director of finance, maybe directors of their company, board of governance. Now, in that case, obviously, you cannot have a sample size of 200 people. Or maybe you are conducting your research on top 1,000 companies listed in stock exchange in your country. And you are asking people that hold the top positions or from the top management. Then obviously, you cannot have a sample of 300 people. In that case, your sample size will be much lower than 200 or maybe even 150 respondents. So you do have to consider your nature of research and then again the type of statistical analysis that you are performing. Now, let's say for exploratory factor analysis cannot be done if the sample has less than 50 observations, which is still subject to other factors, whereas simple regression analysis must have at least 50 samples and generally 100 samples for most research situations. So one has to consider the nature and statistical analysis. Moving on, the type of analysis program that you are planning to use. Now, if you are using CBS-SEM, using let's say AMOS or maybe M+, or maybe Literal, or you are using PLS-SEM using Smart PLS. Now again, the analysis program that you are using could affect the sample. Now, here it all clarified that no multivariate analysis technique, including PLS-SEM, has this kind of magical capabilities. That is, what kind of magical capabilities? Now, many believe that PLS-SEM is a simplified tool to run models with small sample sizes. This argument is most often falsely and misleadingly used. Consequently, many studies are conducted with small sample sizes when they require a large population. If you require a large sample size and if your techniques requires a large sample size, then you must have it. A software program can run any model with any sample size. So you can run, let's say you've got a sample size of 50, you can use AMOS to run it. But obviously, sometimes you do have complications. This does not mean it produces accurate results. Interestingly, with large data sets, 50, 250 samples and above, both CBS-SEM and PLS-SEM may yield similar results. Now again, you need to read this here et al. 2019 for detailed discussion on sample size in PLS-SEM research. The full reference is at the end of this paper. So research supervisor is another consideration. Now, most of the times, research supervisors want their students, scholars to have a much larger sample size. So they are pushing their students to have a large sample size because they want to improve the generalizability of their results and draw better conclusions. Now, again, and there is a different opinion as well. And according to Mui and others, argued that the gains and precision decrease as the sample size increases. According to Hare et al., large sample size can make statistical significance overly sensitive, which can result in type 1 error. In other words, a large sample size can make any relationship statistically significant even when it is not. This is one of the reasons researchers often coincidentally achieve highly significant results. Now again, do not push for higher sample size if you are not required as or in context of your study, the objectives of your study, or the analysis techniques that you are using. Now, there are existing rules, guidelines for sample size, and we are going to discuss them one by one. The first one is sample to item ratio. Now, generally recommended for exploratory factor analysis. When you're doing EFA, you need sample to item ratio. The sample to item ratio is used to decide the sample size based on the number of items in the study. So the ratio should not be less than 5:1. For example, study with 30 items would require 150 respondents. So for one item, you need 5 respondents. So 30 into 5 is 150. A 20:1 ratio has also been suggested. And in that case, a 30 item study will need 600 respondents. Now, both are these guidelines, and you've got reference for both of them. So you can use either one of them. And if you get good results with 150, why not use it? You've got a reference for it. Now, sample to variable ratio. The sample to variable ratio suggests a minimum observation to variable ratio 5:1, but the ratios of 15:1 and 20:1 are preferred because this is too low. This means that though a minimum of 5 respondents must be considered for each independent variable in the model. So let's say you've got 2 independent variables, then obviously you need a sample size of 10. But obviously 15 to 20 observations per independent variable are strongly recommended. Moving on. Now, Craigie and Morgan table, I'm not sure how it's pronounced, so I'm going to call it KMT. So now this is a well-known way to determine your sample size in behavioral and social sciences. Research and no calculation is required. But the problem is we've been using it most of the times in an incorrect manner. It requires probability sampling technique to be used. So again, although it has been used, it requires that you have followed probability sampling for your sample selection. Now, it's a well-known table. You can simply Google it and you will find it. Now, there are a number of online calculators as well, and I have put some in the videos on my channel as well. Now, these KMT tables and calculators are undoubtedly useful in determining the sample size. However, researchers should always be mindful of their assumptions of probability sampling. Now, the one that we use or we've been using in our studies as well is a priori sample size for structural equation models. Now, there are sample size calculators. The one of the famous ones is by Daniel Super, available online. Now, it's a mini online power analysis application that determines sample size needed for a research that uses structural equation modeling. How it is done? Well, I've got a video on it, but I've got one here as well. So let's say my anticipated effect size is 0. Let's say 2. I'm going to go for a moderate effect size. The minimum required statistical power is 0.8. Number of latent variables. Let's say I've got 5. And I've got observed variables. The manifest variables, the number of items is, let's say, 30. And the probability level, as in social sciences, is 0.05. So I've got it here. Now I've got a minimum sample size to detect any effect is 376. the minimum sample size for model structure is 200 and the recommended minimum sample size is 376. So this is your recommended minimum sample size. But what is the difference between these two? So what I did was I used some AI for it. So I gave Daniel Supercalculator these statistics and I asked it to use this scenario to give me the details. The scenario was I had servant leadership as my IV, career commitment as my mediator, life satisfaction as my DV. So what is the minimum sample size to detect effect? Imagine you are interested in detecting the effect of whether servant leadership has a significant effect on life satisfaction. You want to ensure that if there is a true effect, your study has enough statistical power to detect it. Now in that case, for statistical power to detect it, I will need a sample size of 376. Now moving on. Now let's consider the complexity of your model, which includes not only the direct relationship but servant leadership and life satisfaction, or rather the direct effect between servant leadership and life satisfaction, but also the mediator career commitment. Now the minimum sample size model structure would take into account the complexity introduced, including the career commitment in the analysis. It ensures that the relationships between servant leadership, career commitment, and life satisfaction can be reliably estimated. Now, once you add more complexity to the model, and can we estimate the relationships reliably, you need a minimum sample size of 200. But this is the sample size that we are going to focus on, and we are not going to get into the complexity of other things. So let's keep it simple and use this as a minimum sample size. Moving on. Now there is Roscoe's 1975 guidelines, and we've been using this as well, between 30 to 500. And larger sample size may lead to type 2 errors. Now then there is a Green's procedure. Now there are two recommendations. N is greater than or equal to 50 plus 8m, and then N is greater than or equal to 104 plus m, where m is the number of predictors. Now one is for overall variance explained in the endogenous variables, R square, and the other one, this is the next one, is to assess, if you are interested in assessing the impact of each of the predictor on the outcomes, then you are going to use this next recommendation. Now again, if you want to know the detail, just download this paper and read it. Now sample size guidelines for PLS-SEM. Most of the times we've been using the 10 time rule. Now this 10 times rule recommends the minimum sample size should be equal to the larger number of 10 times the larger number of formative indicators. So let's say if you've got formative indicators and I've got 5 formative indicators. So my sample size should be 10 times the largest number of formative indicators. So what's the largest number of formative indicators? Let's say 5. So 5 into 10, so my sample size should be at least 50. Or if I do not have any formative indicators, then it should be 10 times the largest number of structural paths directed at a particular latent construct in the structural model. So I've got a structural model. Let's say I've got one here. Let's say this is the structural model. So there are 3 arrows pointing towards knowledge sharing. So 3 multiplied by 10, 30. So that should be my minimum sample size. However, there are certain problems with this recommendation, and it has been criticized as a valid criterion for determining sample size. So 10 times rules for determining sample size adequacy in PLS-SEM analysis only applies when certain conditions such as a strong effect size and high reliability of the measurement items are met. So it may not be applicable when you may have some reliability issues or you have weak effect sizes, although it has been used in existing research. Now recently, as an alternative to 10 time rule, there have been other methods, and the two methods, one of them, a video is available on my channel and I'll share that as well, is the inverse square root method, and the other is a gamma exponential method. Now, they are based on path coefficient. So if you do not know the path coefficient and you are using inverse square root method, the minimum sample size that you require will be 160. For gamma, you will need a minimum sample size of 146. Now, inverse square root method is the recommended one because of its ease of use in sample size calculation. Now then, there is another method in PLS-SEM, and that is the power table by Hare et al. And how does the power table look like? Here it is. Now here is the table by Hare et al. And in social sciences, we normally use the significance level of 5%. Now what minimum R square do you require? Let's say the minimum R square that I want is 0.10. And I've got maximum number of arrows pointing towards a construct. Let's say it is 6. So I will need a minimum sample size of 157. For more details on the table, I recommend you to read in the book by Hare et al. The reference is available in the paper. Now moving on. Then there is Klein's recommendation, whereby Klein's has mentioned that 100 to 200 is medium, over 200 is large, and less than 100 is small. Again, they have, or rather Klein has mentioned that model complexity shall be taken into account. And then there is multi-level models, and there is 50-20 rule, such as 50 groups with 20 individuals per group. Now again, multi-level models is when you have groups and then levels in your data. And then there are other rules, one by Nunnally, that if one wants to select the best variables from as many as 10 possible ones, there should be between 400 to 500 respondents, as we've seen earlier. So till now, we have seen that a sample over 200, 250, between 200 to 250 can be considered a good sample. Now then, there is G power or power analysis applied through G power software. So it is based on your effect size and the power. So effect size is between 0.02, 0.15 and 0.35. That represents small, medium and large effect size. Normally the minimum level of power is 0.80 or 80%. So let's assume I've got this model here. I've got 3 predictors, 1 dependent variable, or in this case, I've got 3 predictors, 1 mediator and 1 dependent variable. In this case, I've got a moderating variable as well. So when assessing the moderating effect, you will include the moderator and the interaction effect and its impact on the DV as predictor, as done here. Look at this. The interaction effects are all there along with the moderator as a predictor. Now, let's say, how do we use G power analysis? So in this case, you will have 4 predictors predicting the outcome. Now again, how do we do this? So I've got this software here, which is easily downloadable. Once you download it, open it and go to the test family, select F-test. And from here, we are going to select this linear multiple regression, fixed model R-square deviation from 0, and then a priori computed sample size given the alpha, power and effect size. So let's say my effect size is medium effect size 0.15, alpha 0.05, power 8.5, and I've got, let's say, 3 predictors. And now I'm going to calculate. So the minimum or the sample size required is 87. Let's say if I increase the number of predictors to, let's say, 5, calculate, and here is the total sample size, 102. Let's say if I change the effect size to 0.2 and change the predictors to number 7, now I need a sample size, a minimum sample size of 88. So this is how you can use G power analysis for regression-based models, PLS-SEM or CBS-CM. Overall, and the objective of this particular session was to understand or develop an understanding how to or what to do when you have got a survey research and you want to calculate the sample size. Again, this was a very short section, so I strongly recommend you all to read this particular paper. Thank you very much.